Okay, so our goal over the next week or so is to add on to what you guys know about right triangles and expand this into any type of triangle. So basically what people did was they looked at a triangle, and if I wanted to solve pieces of this triangle, and I'm going to use your example that we have down here below that we'll get to in a minute, if I wanted to figure out the other angles and sides of this triangle, I would have to, at some point to find the sides, draw in here a right triangle and kind of split up my work where I could work with this right triangle and that would help me find this piece and this piece. And then because this piece connects to the second triangle, I could then work with the second right triangle to find these other pieces, and I could like add these two together to find the full length down here. That's a lot of work for one problem. So instead of doing all that work, mathematicians saw a pattern that every time they did the same thing. And when you're doing the same thing every single time, there tends to be a way for you to kind of formalize that and turn it into some sort of formula. So what they did was they took this idea and they found different expressions for the areas of these triangles and set them equal to each other and came up with a new formula that relates angles and sides together in any triangle that doesn't have to be a right triangle. Now, in the formula, we're going to use the letters A, B, and C. But of course, a triangle could be labeled with X, Y, and Z, P, Q, R. It doesn't matter. But remember that capital letters stand for the angle and the lowercase stand for the side across from it. Okay? So that's what you see here. And here is your law of sines formula. It says if you take the sine of angle A of this triangle and you divide it by side A. So if you take the sine of this one angle and divide it by the side across from it, you get the same exact thing if you did that to another angle in the triangle or to any other angle in the triangle. So this basically says there's a ratio that's equal in all triangles. If you take sine of an angle and divide it by the side across from it, you will get the same answer no matter which angle side pair you do this for in the triangle. So that means when you look at a triangle like you see here in example 5, I would basically kind of go through this process. First, is it a right triangle? If it is, use the trig that you already know how to do. If it's not, then you want to use law of sines, if possible. Sometimes it won't be possible, and we'll find a solution to that shortly. So I look at this triangle. There's nothing in it to indicate that it's a right triangle, and I'm supposed to solve it. Solving it, remember, means to find missing sides and missing angles. So I got to find angle C, side C, and side B. Angle C is probably the easiest thing for me to find right away. Because triangles add up to 180, I can subtract the angles I already have here and figure out the measure of angle C, which turns out to be 80. And unfortunately, that has confirmed for us this definitely is not a right triangle, which normally would make us feel stuck, or we'd have to go back to this idea where we have to start drawing in all these new types of triangles to make this work. But instead, we have this new tool called the law of sines. So remember, the big deal, why would we even do this, is because you can do this for any triangle. It doesn't need to be a right triangle. So I'm going to use angles and sides, and I want you guys to remember, just like when we set up our trig equations, in order to do this problem, we need an angle and the side across from it. And we need to set that equal to another ratio using sine with a different angle of the triangle and the side across from it. So notice how many pieces of information are being used here. I need 4 things to fill in, and I only want one of them to be unknown. Okay. So let's say that I am looking for side length C. So I want that to be one of the things in my equation. I now would want everything else that I have to fill into these boxes to make my equation to be a number, okay? Angle C is 80 degrees, so I have that. Then I need an angle and a side across from each other that are both numbers so that I can actually solve this equation. So I only have one other side. It's across from the 40-degree angle, so I'm going to use the 40-degree angle and the 20 length side here. And then just like we were doing previously, we can actually figure out some of these values and solve that problem using our proportion knowledge. So I'm going to use my calculator and I'm going to figure out the sine of 80, which is 0.9848. And that's over C. And the sine of 40, which is 0.6428 over 20. And I'm just going to go ahead and cross multiply to solve. So I'm going to multiply 0.9848 times 20 and get 19.696 equals, this decimal is going to multiply C, and to get C alone, I would divide by that decimal. So my answer is going to be what I get when I take 19.696 and divide it by 0.6428, which gives me 30.6. And that has found this side length C for me. It seems pretty good because it should be longer than the other side because it's across from the largest angle. And so that works pretty well. Now, you guys are used to having some options here. You usually can go ahead and do multiple things to solve for the third side, but here you don't have a lot of choices. You cannot use Pythagorean theorem, okay? Because this is not a right triangle and that is limited to right triangles. So I'm going to try and use the law of sines again, okay? But this time I want to find B. So I want B to be the side length in one of my ratios. And in order for that to happen, I have to use the side across from it in that or the angle across from it in that ratio, which is 60. Then I want another equation where all the numbers are filled in. So I'm going to go back to relying on the fact that that 40-degree angle is across from that side length of 20. And I'm going to do sine 40 over 20. And then I'm going to go ahead, turn these into decimals. I'm going to cross multiply and solve. So the sine of 60 is 0.8660. And the sine of 40, we already did, is 0.6428 over 20. And now I'm going to multiply 20 times 0.8660. That's going to give me 17.32 equals, the decimal is going to multiply times B. And so now to find my final answer, I am going to take 17.32 and I'm going to divide it by 0.6428, giving me 26.9. And again, that seems appropriate because it should be bigger than the 20 length side because it's across from a bigger angle, but smaller than the other side. All right, so that solves this entire triangle, all using that law of sine. So really our goal here is that you can appropriately use these formulas that we're going to discuss today. For part B, we're going to do the same thing, and I'm going to make a note for you guys, and it might not make much sense given that we're using this more in an application sense instead of learning all the theory with it, but if you're not sure about a triangle, you should save the largest angle for last. So what I mean about this is when we look at this triangle, we have to find two angles, angle B and angle C. And we also have to find side length C. This one's across from B and this one's across from A. Now, what I know is I know that angle B is not the biggest angle. Okay, so I'm going to actually try to find B first because I'm going to try and save bigger one for last. It's the way that the calculation is done with the calculator that it actually won't find an obtuse angle, so you have to kind of carefully figure it out. So I'm going to find B. The reason I know that it's not the biggest angle is because B is across from 57 and 42 is across from 63. Since 57 is smaller than 63, then angle B should be smaller than 42. And I know it wouldn't be obtuse. Okay, so this means when I set up my equation for this problem, I know I want to use angle B. I'm going to look for that. And that's the angle, so it goes in the top of the ratio with the sine, and in the bottom of the ratio goes the side across from it. Now, I need another ratio from the triangle, and I need all the information to be included because I already have my missing piece of B. I don't want anything else missing. So I happen to have a side across from a given angle, so I can set those up in the other ratio so that I have all numbers besides that B value that I'm looking for. So this would be sine of 42 over 63. And then I can go ahead, and if you're more comfortable with numbers, you can find out what sine of 42 is. So I'm going to find in my calculator sine of 42. It's 0.6691. And then I'm going to go ahead and cross multiply. So 63 is multiplying with sine of B. And then 57 is multiplying with 0.6691, giving me 38.1387. I'm going to divide by 63 because I'm working to get B alone. And I'm going to have that the sine of B is equal to 0.6054. And remember that the last step in these problems where we're trying to find an angle is to take the inverse sine to get rid of the sine function. And this is actually the reason why we have to save bigger angles for last. So this will leave us with angle B, which will be equal to the inverse sine of this decimal value. And so 0.6054, and I'm going to take the inverse sine of that, gives me 37.3. And that's a capital B that represents an angle, so that's going to be in degrees. Now, because angles add up to 180 degrees, I can find this third angle by taking 180 and subtracting from that the total I have so far. So the total I have so far is 79.3. If I subtract that from 180, I get 100.7. And now I need to find side length C. And again, you guys are really going to have to break yourself of the Pythagorean theorem habit if you're not doing a right triangle. So to finish this and to find C, we're going to have to go back and try to use law of sines again because we can't use the Pythagorean theorem. So I want to find side length C. Side length goes in the bottom. Side length C is across from angle C, and I figured that out to be 100.7. So this is going to say sine of 100.7 over C equals, and again, here I want a full ratio that has all the numbers, and I had that from the beginning if I use the angle 42 and the side across from it of 63. So I'm going to figure out the sine of 100.7, which is 0.9826. Over C equals, We already found the sine of 42. It was 0.6691. And now I'm going to cross multiply. So 0.9826 is getting multiplied by 63, which gives me 61.90. And I'm trying to keep these decimals, and I'll round at the very end. If you round too early, you'll lose a lot of accuracy in your answer. And then the other decimal, 0.6691, gets multiplied by C. And to get C alone, I'm going to divide by that decimal. And so I'm going to divide by 0.6691. And that gives me 92.5. And that's a side length because it's a lowercase c. And then there's my solution for this triangle. Now there are some situations where this is not going to be enough, which is why we also have the law of cosines, okay? So the law of cosines was made very similarly to the law of sines, that you have these triangles, you see this need without having to draw new ones all of the time to create that. And so they went ahead and categorized these laws. So again, be aware of the letters that we're using, the lowercase being the sides and the uppercase being the angles. So these formulas start by looking like Pythagorean theorem, but then they have a part they subtract off of there. So be a little bit careful here. This uses a lot of the pieces of the triangle. So these are all sides because they're lowercase letters. And this one's an angle. This is specifically the angle across from the side that you are using on this part of the formula. So if yours isn't labeled with A's, B's, and C's, you cannot get caught up in the letters. It's basically like there's a side and an angle across from each other, and they're used in those places of the triangle, and then the other two sides would be considered like A and B. These are the other two sides of the triangle that show up in the rest of the formula. And this formula can be used any way with any of the three angles and sides of the triangle, so you might see it written these other ways as well. Again, they don't have to use these A, B, and C letters. So just be aware of what we're actually using in the formula. So again, side across from, sorry about that, fix this angle here. Side across from the angle, okay? So these ones are across from each other, and then these other ones are just the other two sides of the triangle. Okay? So I'm going to give you an example here where we're going to draw the triangle. Notice that they're using the letters A, B, C. So you give yourself any triangle, and you label the angles with capital letters. I'm going to use A, B, and C. And then remember that across from those capital letters you're using for the angles are the lowercase letters for the sides. So A, B, C. And so here's what we know. Lowercase c is 27, that's a side length. Lowercase b is 22, that's a side length. Uppercase A is 47, that's an angle. Notice why we can't use law of sines here. So honestly, you guys, I first ask myself if it's a right triangle. If the answer is yes, I use the basic trig you guys know from before. If the answer is no, I try to use law of sines because I like that formula a lot better. And if I can't, I move on to law of cosines. So when I look at this triangle, there's nothing here that indicates it's a right triangle. So I cannot go down this path. So I go down the other path and I first start with law of sines. Okay. If I tried to set up law of sines for this problem, remember we have to use an angle. The only angle we have is 47 and the side across from it. But then the other angle would be empty and we'd have the side across from it. And notice that we would have two things we were looking for in one equation, and that's not going to work. So law of sines doesn't work here, and then that's how I know that I need to incorporate the law of cosines. Okay. We're solving the entire triangle. So the first thing we're going to do is we're actually going to solve for this side, because if we had that side length, we actually could use the law of sines. Okay. So I want to solve for lowercase a, so I'm looking at the formula like this. I want to use lowercase a for side A, and I want to use the 47 for the angle across from it. So side across from this angle that's going to come at the end of my formula. What does the rest of the formula look like? It uses the other sides of the triangle. And remember that cosine of 47 is a decimal. And that decimal needs to multiply all of these things right here before you should do any addition or subtraction, okay? So this a squared has three things happening after the equal sign here. 22 to the second power is 484. Plus 27 to the second power is 729. Minus, there's a giant multiplication problem over there, okay? I have to find the cosine of 47, and that decimal, whether you can write it down with 4 decimal places or just keep it on your calculator like this, it needs to multiply times 27 and times 22 and times 2. And the answer to that is 810.2141. Now I'm going to do all of this arithmetic, okay? I'm going to do 484 plus 729 minus 810 with that decimal. So 484 plus 729 minus 810.2141 equals 402.7859. I'm almost done now. I just need to square root that number. And that gives me 20.1, which equals A. So I now know that A is 20.1. I'm still missing angle B and angle C, but I found out that A is 20.1. Now I can actually use this formula that I crossed out for law of sines, because now it would look like sine of 47 over 20.1 equals sine of B over 22. And this is now solvable because there's only one variable. So I'm going to find the sine of 47. So 0.7314 over 20.1 equals the sine of B over 22. And then I'm going to cross multiply. So 0.7314 is getting multiplied by 22, which is 16.0908. And that's equal to 20.1 times the sine of angle B. And I'm going to divide by that 20.1 because I'm trying to get B alone. So when I divide by 20.1, I get 0.8005 equals sine of B. And remember how we solve for an angle every time we get to this point. We need to take the inverse sine of both sides of this equation, and that will give us that angle B is equal to this calculation that we need to do in our calculator with the inverse. So angle B is equal to 0.8005, the inverse sine of that, which is 53.2. That's a capital letter, that's degrees in this triangle. And then remember to find this last angle, because I have the other two. I can now do 180 minus the total I have so far. So I'm going to figure out what 47 plus 53.2 is, and I'm going to subtract that from 180 and get 79.8. And then I'm actually going to change the second example a little bit because this one is set up really similar to the first one. I'm going to change it so that this lowercase a is equal to 12. So that we actually have all three sides of the triangle here. So again, I'm going to draw a triangle ABC. Remember, lowercase a is across from big A, lowercase b is across from big B, and lowercase c is across from big C. So now to solve this triangle, this is a little bit unique here. We need to find the measure of angle A, the measure of angle B, and the measure of angle C. And if we have those three things, we're done because we have the three sides, but not any of the angles. So again, we have to use law of sines here, or law of cosines. This is not a right triangle, and if I tried to set up law of sines, I would have too many empty spaces where I couldn't solve. So I am going to use law of cosines to solve for an angle. You can pick any angle. So let's say I decide to solve for angle B. That means in my law of cosines equation, I want B to be the letter that comes after the cosine. That means on the other side of the equation, if you remember the letters that went in our formula, it looked like this. So that means I want the side across from B, the 6, to be on this side, and the other two sides are filled in here for my equation. Now the reason I really wanted you guys to see this one is it's tricky to solve. You guys know what you're doing to plug in. You have the formula in front of you. It's the solving that gets everyone. So we have 36 equals 144 plus 100 minus 240 times the cosine of B. And here's where it gets tricky. People want to combine together all the numbers they see. These two numbers can combine together. They cannot combine with the 240 because the 240 is not 240. It is 240 being multiplied by the cosine of B. So I now have 36 equals 244 minus 240 cosine of B. And I want to get B alone, but B is part of this here. So the first thing I'm going to do is subtract 244 so that all the numbers that don't have the variable with it are moved to the other side of the equation. Now this gives me negative 208 equals negative 240 cosine of B. Now to get B alone, I'm going to isolate cosine of B first. So I'm going to divide by negative 240. So I'm going to do negative 208 divided by negative 240, and that gives me 0.8667. Equals the cosine of B. And now we're right back where you've been several times when you've been solving for angles during trigonometry, where you have to take the inverse cosine of both sides of this equation in order to finish solving. So you'll get angle B is equal to what you get in your calculator when you do the inverse cosine of 0.8667. So I'm going to do that here, and I'm going to get 29.9. So I get that angle B is equal to 29.9 degrees. And now you guys, always when you do the law of cosines, you then end up able to do the law of sines because it's solving your missing angle or your missing side, and then you have that pair that's across from each other again. So now I'm going to set up law of sines to help me finish with another angle. So I'm going to use sine of the angle I have over the side across from it equals sine of a different angle that I want to find. I'm going to say C, and the side across from it. 9.9, which is 0.4985. And some of you might be able to solve this faster, and that's fine. We're going to multiply that decimal by 10, and we're going to get 4.9849. Excuse me, 4.985 equals 6 times the sine of C. And then because we're trying to get that C alone, we're going to divide by 6. So 4.985 divided by 6 is going to give us 0.8308. And again, when we're solving for that angle, we're back at that place where our last step has to be to take that inverse sine of both sides of the equation. So here, angle C will equal the inverse sine of that 0.830. Sorry, that should have had an 8 at the end as well. Which is 56.2 degrees. So angle C will be 56.2 degrees. And then remember, once you have two angles, we're not going to do this third example, so I'm going to cross this out. To find the last angle, which in this case is our angle A, we can do 180 minus the angles we have so far. So 29.9 plus 56.2. So 29.9 plus 56.2, and if we subtract that from 180, we get 93.9. And this is where it's really important that we saved the best for last kind of thing, or the biggest for last to solve, or we wouldn't have got that number that's over 90. So really our goal here is that we've given you two types of formulas. We want you to be able to use both of them and use them appropriately. So that's your goal, to be able to solve adequately using these formulas. So you're going to try and practice this on homework, skill 4 and 5 homework, and the solutions are posted for you to check. And then we will answer lots of questions about this on our next period that follows this.